Hey, what's up? We're looking at the source code for Apache Kafka. This is ants are everywhere. And we look at source code. So Kafka, you all know it. Some of you may love it. And I've never used it. But people seem to like it. It said, Wikipedia describes it as a distributed event store and stream processing platform. So, like for like messaging middleware. We've looked at the Raft and Code, I think, is maybe the only other message middleware we've looked at. We've looked at a bunch of databases which share some similar principles. And we've looked at a bunch of distributed systems which share other similar principles. Wikipedia is telling us a little bit here about the architecture. It is a distributed log-based messaging system that guarantees ordering. The ordering is guaranteed within individual partitions rather than across the entire topic. I'm not sure how to think about that. I guess that I'm not sure what the relationship between partitions and topic is. I guess maybe partitions might be more like the machines, and a topic can be spread over multiple partitions, but I'm not sure. Unlike queue-based systems, Kafka retains messages in a durable, append-only log, allowing multiple consumers to read at different offsets. And they use manual offset management, giving consumers control over retries and failure handling. Okay, I don't know what an offset is. In 2025, Apache Kafka introduced queues for Kafka, adding share groups as an alternative to consumer groups. Okay, so let's see if we can find Kafka architecture, just to give us a little bit of a head start here. I don't know how accurate these are, but we'll just take a peek. Whoa. Open. Okay, so a cluster has multiple brokers. I'm guessing I don't know if broker is a term of art or if it's just a generic description of what Kafka is doing. And then they are using Apache Zookeeper to do the Zookeeper stuff, to synchronize all of the... So everyone has the same version of time, essentially. And then we have producers and consumers. And the producers push messages to the broker. You can't really see that because of maybe because of Dark Reader. Yeah, they push messages to consumers, and somehow they get a broker ID. I don't know if they have a unique ID per message or per producer. And then you pull messages, and you update offsets. Maybe offset is just like where you are in the append-only log. So this is just some log of stuff that happens, and you keep essentially like a pointer, I assume, to the last thing you read, and maybe that's what it's calling an offset. Kafka explained. Here's another architecture diagram. We have producers, and we have a cluster, and the cluster has a broker in all caps. And then this is some description of a partition. It says commit log guarantees ordering, easy scaling. So in this, I'm guessing these are all supposed to be brokers, even though only one is labeled. And there are topics. And I guess the topics are 0, 1, and 2. Although I don't know if this is supposed to be like a database of a single topic. But I'm guessing these are supposed to be separate topics. And then you have users and metrics. I'm not sure what that is saying about users and metrics. Or I don't know, for example, if all brokers serve the same topics or not. But these are questions I guess we can ask. Why don't we ask DeepSeek? I never asked DeepSeek anything in Apache Kafka. Does each instance serve... tell me about, succinctly, about the relationship between Kafka broker instances broker and topics, I guess. Can you read a topic from any instance? Or does each instance only serve a subset of topics? Probably with replication if they do it that way. Let's just ask that. See what you can tell me. Mr. DeepSeek. A Kafka broker instance is a single server in the Kafka cluster. A topic is a logical category or feed name into which messages are published. Okay, so broker serves many topics. Sure. But we knew that. A topic is spread across many brokers. I think we also knew that even in the case where every broker doesn't serve every topic, can you read from any instance? Absolutely, yes. This is a key feature of Kafka. You only need to connect to one broker, a bootstrap server. The broker will tell the client which broker is the leader for the partitions of the topic it wants to write or read from. The client then communicates directly with the correct leader brokers for each partition. Okay, so this sounds like no, you can't, but there's like a you talk to the you get pointers to the instances to read from, and then these instances have leaders. So I guess they do I forget if Apache Zookeeper does Paxos or Raft. I think those are pretty much the only two games in town. But let's assume for the sake of argument that they do Paxos. So then they're all doing, I guess, Paxos within each partition, I think. And then they're also doing it to have a broker. I'm sorry, no, the bootstrap server. Although maybe the bootstrap server is really only a reverse proxy or something. Each broker acts as a gateway and knows the complete metadata of the cluster. Okay, so this is suggesting maybe every broker can. I don't know. So is each broker a bootstrap server? That 2 is the bootstrap server. Just a reverse proxy, I guess. And then 3 does, what's the relationship between partition and topic? We'll start there. My wife was pointing out that there's a golden rule in emails that you never ask more than one question per email, but that seems to be a human limitation because LLMs are pretty good at responding to multiple questions. Hamza is asking, the bootstrap server is the broker instance that a producer-consumer connects to initially. Thank you, Hamza. You know what? I wish that chat would give me times. Well, give me times? Timestamps. Oh, look at that. What a world we live in. Okay, so it's getting, maybe, is the broker instance of producers? Yes. But is that can you connect to anyone is basically what I'm asking, or do you need to have a specific dedicated bootstrap service? No, it is not a reverse proxy. Okay. It's a metadata gateway. Its only job is to answer the client's initial question. Here's a map of the cluster. Okay. Sounds like really anyone can answer that. And then what's the relationship between partition and topic? This is the core to Kafka scalability. A topic is a logical category. A partition is an ordered, immutable log that makes up a shard of that topic. And I think it probably means a shard is doesn't contain the entire topic. A topic is like a book title. A partition is a chapter in that book. And then messages within a single partition are guaranteed to be in the order they were written. So within a shard, order is not guaranteed across different partitions of the same topic. And then parallelism, partitions allow for a topic to be split across many brokers. This enables parallel consumption. And then unit of replication. Each partition is replicated across multiple brokers for fault tolerance. And message key. The producer specifies a key for a message, for example, a user ID. All messages with the same key are guaranteed to go to the same partition. Okay. So then, all right, so, and what is, and how are partitions stored on disk? Are we talking, or in RAM? We're talking like a D tree or key value, or, and let's look up Apache Zookeeper. I don't know how up to date Wikipedia will be because this article is probably written in like 2012. Let's see. Doesn't seem to really say explicitly. It supports high availability through redundant services. Apache Kafka algorithm. Raft. The consensus protocol that was introduced in Kit 500 to remove Apache Kafka's dependency on Zookeeper for metadata management. I must have looked up Kafka because it looks like this is saying that they don't use Zookeeper, and maybe they use a custom like Raft thing. Apache software. Okay, so it sounds like they do Raft, but what I really wanted to know is what Zookeeper does. I'm guessing it's Paxos. We have a simple algorithm. Isn't this just multi-Paxos? No. Maybe it doesn't use Paxos or Raft. It is neither a B tree nor a key value store. It's a simple append-only log of immutable files. Okay, this is its simplicity and its power. It sounds like it's saying even on the disk, like it's just a file, and then an offset index, and reads. So writes are sequential, reads are mostly sequential, and immutability. And then there's an index. And they just provide random access by keeping a record of the offset. Okay, and there's some stuff about page caching, which we will ignore. And I'll take the Zookeeper. Does Zookeeper do Raft or Paxos or something else? And 2 has Kafka move away from Zookeeper to use Kraft. These are excellent and very current questions. I'm so good at asking questions. The move away from Zookeeper is one of the biggest recent changes in Kafka. Zookeeper uses its own consensus protocol called ZAB. Zookeeper Atomic Broadcast. It's similar to Paxos in its goals, but it was designed specifically for Zookeeper's primary use case, maintaining a state machine with a leader and followers. It's not Raft. Okay, and so yes, Kafka has moved away from Zookeeper to use Kraft. Okay. Draw a picture. I don't know if DeepSeek can draw pictures of Franz Kafka eating Kraft dinner while reading. How about while writing a manuscript at his kitchen table. Let's see if you can do that. ChatGPT for shorthand. Let's see what they all got. Do I want to burn pro credits here? Yes, I do. Nothing. You got nothing for me, DeepSeek. Conceptualizing the scene. Okay, it's not bad. It does not look like craft dinner. It looks more like cereal. Let's try Flash. I realize I haven't cloned Kafka, so I'm not going to be able to do some things like use tags with it, but that'll be fine. I'm also working from a mirror. That's actually why I opened up Wikipedia in the first place. Let's see if I can find the official. Oh, whoops. Whoa. Wikipedia is linking to the GitHub page. I thought they said it was a mirror. Yeah, mirror of Apache Kafka. Okay, I don't know where the official non-mirror is. Okay, so Gemini Flash is refusing. This is much better. This is good. Great. Awesome. This is just the text. Okay, so make him like he's been transformed into a bug. All right, and so while it's while it's doing that, let's see if we can figure out what's going to be cool in Kafka. I guess I don't feel like I want to be here all day. I want to see if I can maybe get the highlights. This should be mostly Java, maybe mostly Scala. Java 86.8%, Scala 10.9%, some Python, maybe just for testing and stuff. Or like, what's the word? Scripting, but more portable than Bash, portable shell scripts. Okay, there is a Raft directory. I'm not going to look too closely at Raft. I don't think this is probably the place to learn to dig into Raft. We have a source for the server. I don't know if that's going to be cool. Core is maybe where a lot of the stuff is going to be. Examples might be good for some stuff. Connect, probably not the most important. Clients, I don't know. Bin, could go either way. These are shell scripts. And what else? Storage and streams probably are might be cool. And whatever Trogdor is, a test framework. FTP is still working. It's very slow to generate images, you know. Here's Raft, Kafka Raft. It's based on the Raft Consensus Protocol, tailored for Apache Kafka. Okay. Probably in Java. I mean, what else would it be in this Java code base? Okay, so there's lots of stuff here. I'm not going to look at it. I guess I don't even know I opened up that much. I'm going to start, I think, with core. And maybe let's just pop core into its own thing. Source. This is Java, so you have to really dig in to find any code. And of course, Java and Scala have to be in different directories, which is not, in my opinion, great. We probably don't care about Docker. But in Kafka server, we have builders, handlers, logger, share, and network utils quota factory, replica quota, and tier state machine. And then in Scala, we have admin, cluster, controller, coordinator, log metrics, network, Raft. This is maybe being a consumer of Raft as opposed to, or maybe just like bindings for working with the Raft library, because we saw the Raft library is in its own folder. And server. and then Kafka.Scala, which is some sort of entry point, which I'm guessing is not going to be so fascinating. No. We're going to try, let's see. We're going to attach in a shutdown handler to catch terminating signals, which is just going to call shutdown. And then after doing that, we're going to try to start up the server. And this is, I guess, one server. Yeah, okay. So here we go. Kafka as a bug, eating crap dinner and working on a manuscript. It's not bad. Okay, and in a cluster, we just have Partition.Scala, which I think that it seems like partitions are the main thing that that Kafka, like the servers, really know about. And what do we got here? I don't know any Scala, by the way. I don't really know how to read it. A listener receives notifications from an online partition. A listener can be re-registered to an online partition only. The listener is notified as long as the partition remains online. When the partition fails or is deleted, respectively, onFailed or onDeleted are called once. No further notifications are sent after this point on. Okay. So there's an on-high watermark updated for when the log increments its high watermark. This is append only, right? So wouldn't the log always be reaching its high watermark? I mean, it's not decreasing in size. So I'm not sure. And then we have onFailed, onDeleted. These are a trait, which I guess is Scala for enum, or interface, rather. And then alter partition listener. You can alter it. We've got delayed operations, which have a topic ID, a topic partition, produce, fetch, delete records, etc., check, complete all, and so on. And then we have an object partition. So this is some object, which I think is similar to a struct, but in functional land. And what methods do we have? We have apply, which is going to take a topic ID partition, a topic ID partition, something about topics, something about IDs, and something about partitions, but how they all relate, I'm not sure, and a time, and a replica manager. And I guess this probably means it returns this. And what it's going to return is a partition of, we're just going to stuff this stuff into a struct, essentially. And that was what? That was apply with these arguments. And then if you add a topic ID, which is an optional, so I guess IDs are UIDs, which makes sense so that maybe some clients can create a topic ID without talking to the database. If we create one, then, so if we call apply, what is going on here? So these are sub-functions, and we close down here, but we're going to return this. I'm not really sure what we were doing. We're defining some additional functions. No, we're not. We're going to say is our change listeners this thing? We're going to create a new one. And then where does this end? Oh, no, okay, so I see. So apply goes down all the way down to remove metrics. Okay, so these are just defining things, and then here's where we create the partition. And we just use the stuff we defined above, including delayed operations and stuff like that. Okay, I told you I didn't read Scala. You didn't believe me. Okay, partition state includes only the in-sync replicas, which have been committed to ZK. They don't use, I assume ZK is Zookeeper, which they don't use anymore. I think this comment is probably just out of date. Is R, I don't know what is R is, or ISR. and some maximal ISR, etc., in flight. Okay, this is telling me some things. Here's partition. A data structure that represents a topic partition. The leader maintains the AR, ISR, cur, and RAR. Partition is thread safe. Operations on partitions may be invoked concurrently from different request handler threads. ISR updates are synchronized using a read-write lock. What does it mean though, ISR? Read lock is used to check if an update is required to avoid acquiring the write lock. In the common case of replica fetch, when no update is performed. ISR update column condition is checked a second time under write lock before performing the update. Okay. I can probably make this text bigger. Is that better? Do you guys like that? Maybe you can make it like almost big enough to be. There we go. No, it doesn't like that. If I go too big, it gets angry. Okay. So, I still don't know what ISR stands for, but what it is doing is it's got this read-write lock behavior. So there's locking, which means that there's going to be lock contention, and that's fine. So various other operations like leader changes are processed while holding the ISR write lock. This can introduce delays in producing replica fetch requests, but these operations are typically infrequent. So produce and replica fetch requests are infrequent. Okay. Hardware updates are synchronized using ISR lock, read lock. I guess that's probably what HW is. I'm not sure. Log lock is acquired during the update with locking order partition lock goes to log lock. Lock is used to prevent the follower replica from being updated. While replica altered dir thread is executing, maybe replace current future replica. Replace follower replica with the future replica. Okay, that's just a bunch of information about locking. But what does a partition have? It has a topic partition. It has a replica lag time max milliseconds as like the second argument, which is kind of interesting. So just some maximum replica lag time. A local broker ID, which maybe means local to the like instance running on the machine. A local broker epoch supplier. A time of what? Seems like a partition would have a lot of times. Maybe it's just like a clock. Maybe it's like the time it's created, or maybe it's just supposed to be per message. Alter partition listener, delayed operations, metadata cache, log manager, alter ISR manager, and a volatile thing, which is a topic ID. So this is going to change, I guess, frequently. And these are just kind of setting stuff up. And did I see something about more stuff about high watermarks? This set may include uncommitted ISR members following an expansion. This effective ISR is used for advancing the high watermark, as well as determining which replicas are required for AX equal all produce requests. So, just look up Kafka ISR. So it's an in-sync replica. Understanding ISR is crucial for anyone working with Kafka. The set of replicas that are fully caught up with the leader replica of a partition. So these are replicas that don't have any, that are caught up. We don't have any more syncing to do. Okay, so we'll maybe come back to partition.scala. I feel like it told us a little bit about what's going on. But let's look at maybe the controller, the state change logger. So maybe this is just going to log state changes. Simple class that sets log ident appropriately depending on whether the state change logger is being used in the context of the Kafka controller or not. Okay. I feel like we're not really there in terms of like finding the real code. So the coordinator has a group and a transaction. And the group has coordinator, partition writer. That seems like it might be involved in writing the partition. And transaction has transaction coordinator, transaction log, marker channel manager, marker request completion handler, and transaction state manager. Let's look at some of these. Maybe we'll look at transaction state manager. Okay. It's part of the transaction coordinator. It manages the transaction log, which is a special internal topic, the transaction metadata, including its ongoing transaction status, and the background expiration of the transaction, as well as the transactional ID. And some stuff about locking. Okay, so the transaction state manager has a broker ID, a scheduler, a replica manager, metadata cache, transaction config, still some time, and some other stuff. Okay. So just let's read some random stuff. So lock protecting access to the transactional metadata cache. So this is just declaring a lock as a new reentrant read-write lock. Shutting down is an atomic boolean. Transaction metadata cache is a mutable map. And some other stuff. Partition load sensor, add metrics. So this is some metric gathering. Transaction version level, add loading partition, which is visible for testing only. Transaction partition and leader epic, we're calling it, with some locking stuff. Here's some iterable. This is the best effort expiration of an ongoing transaction, which has been open for more than its transaction timeout value. We do not need to grab the lock on the metadata object upon checking its state, since the timestamp is volatile. And we will get the lock when actually trying to transit the transaction metadata to abort later. Okay. So, where can we find some stuff? So this is writing some tombstones for expired transaction IDs. And it's going to take a transaction partition, which I'm guessing is a partition that the transaction is about, or is working in. Expired for partition, which is an iterable transactional ID, coordinator, epic, and metadata. And some tombstone records, which are memory records. And we're going to create a function called remove from cache callback. And we're going to iterate over all the responses that are passed in and presumably remove them. And I'm just going to ignore that. And then in read lock, so we're going to, this is, we're, I guess, routing this lock for reading. We're going to append records to the replica manager with some timeout stuff. And setting required acts to this thing, enforce required acts. I'm guessing this is essentially a new. I don't think this can be data. Internal topics allowed is true. Origin is append, origin coordinator. Entries per partition is whatever this thing is, taking a max of some stuff. And setting a response callback, which is the remove from cache callback. Okay. And the request local is set to no caching. And so, what was this doing? Write tombstones for expired transactional IDs. Okay, so we are writing tombstones, which explains, I think, why we are appending records. Where does it say that we are writing tombstones? Here, maybe? We have some map that maps the topic IDs to tombstone records. And we are, I guess, I think this is saying maybe as a side effect, we're removing them from the cache as well as tombstoning them. And tombstone records came from here. And does this remove from cache callback actually? I don't see where it says, okay, here maybe. If transaction state dead. I don't know where it actually says what the tombstone value is. but I'm also not reading super closely. Enforced required acts to internal topic, blah, blah, blah. I don't know. But somewhere it's writing tombstones, or maybe it's down below. Maybe I haven't finished the function. I'm not sure, but I'm just going to move on. What else do we have? List transaction states. This is for listing some transaction states, I guess. Here is get and maybe add transaction state. Okay. Well, this is all well and good. Let's see if we can find some more. I can't quite tell if this code is doing anything interesting yet. Here's a transaction log. Messages stored for the transaction topic. Messages stored for the transaction topic represent the producer ID and transactional status of the corresponding transactional ID, which have versions for both the key and value stores. Key and value versions are used to evolve the message formats. Okay, so we have versions for the keys and values, and that lets you evolve the message formats. That makes sense. So for the transaction topic, represent the producer ID and transactional status of the corresponding transactional ID. So I'm not really sure what a transaction in this case is. Maybe we can look at Kafka transactions. Everything is ultimately append, right? Blocks can never get to the point. Let's ask Gemini Flash. Succinctly, what's a Kafka transaction? Provided, so it's atomic rights to multiple topics and partitions. They assures that they're either successfully committed and made visible to consumers or none of them are. Can they also do reads as part of the transaction? No, it only involves rights. Okay, so the consume, process, produce pattern, which is what transactions are often used for, separates the read and write operations. Okay. So only the writes are atomic, but you can write multiple things, different topics. That's really all that we're doing. It seems relatively straightforward. You try to write, and if any of it fails, you, I guess, roll back them all, and then you say that there's an exception. But we have a transaction log, and we've got something like whether compression is enforced. We have here the payload bytes for transaction log message value, and so on. Read transaction record key decodes a transaction log message. All right, so that's still not where we want to be. Transaction coordinator is also not really where I want to be, but we can maybe look at this. So we have the transaction coordinator, which has an apply method, which takes a Kafka config, a replica manager, a scheduler, a create producer ID generator, some metrics, metadata cache, and time. And then we have this transaction config object, which is basically a struct with config. And so here's the method, and all of these things, I guess, are part of the method until we get down to init transactions and the other. We're just returning the coordinator, passing in a bunch of stuff that I guess we may have computed. So it's a constructor. But no. It's the apply method, right? So apply is basically, I think that maybe what's going on is so this is what transaction coordinator is that we're returning. I think that with what we're doing is we have immutable stuff, and the reason we're returning the new thing is that's kind of how mutation is done. We're returning a new mutated thing, and that's part of, or maybe a big part of how we get thread safety. I think it's probably the idea why this is essentially just a constructor. So what is it mutating? You've got this transaction config. It just seems to like be passing stuff in. I guess maybe the mutation happens before you call it. Like you just you don't know. You don't give it an old transaction coordinator, do you? Maybe we're just thinking of the apply as being like you're applying the config or something like that. I'm not sure. I don't know how to think of this yet. Handle init producer ID. So you might be asked to initialize, I guess, a producer ID. If the transactional ID is null, then always blindly accept the request and return a new producer ID from the producer ID manager. If the transactional ID is empty, return an error. If the request is to keep the prepared transaction, then return an unsupported version error since the feature hasn't been implemented yet. Okay. Check transaction timeout milliseconds, if not larger than the broker configured maximum allowed value. All right. Otherwise, we're going to compute resolved transaction timeout milliseconds. We've got this convert coordinator epoch and metadata thing, where we're going to get the transaction state on the transaction ID and map stuff over it. And if the ID is none, we do some stuff. Otherwise, if it's some epoch and transaction metadata, we're going to say that we're just going to return it. So really, what this map is doing is just handling errors, I guess. And some more stuff down here with match left and right. Prepare epoch fence. Okay. I feel like the transactions are not as cool as I thought they would be. Let's go back to the Scala server. What else was there? Scala network, request channel, socket service. Let's ignore network. I feel like that's going to be something we don't really need to look at. Transaction, I think, is not so cool. Server, we have ACLs, alter partition manager, auth helper, auto topic creation manager, broker blocking sender, maybe broker service, broker lifecycle manager, delayed fetch, delayed produce, dynamic config. I don't know. Kafka APIs, possibly. Kafka broker. Raft service. I guess why not? The server itself. The shared server. Let's look at some of these, see if we can find any more juice. So broker server is a Kafka broker that runs in craft mode. So we've got some config, some shared server.time. I still don't know whether time is a clock or a timestamp. I feel like it must be a clock, but why not call it a clock? Some Raft manager, which we're going to get from shared server. So maybe shared server is like all the globals. Create a fault handler factory. Standard fault handler factory, which is used when we're not in a JUnit case. Shared server manages the components which are shared between the broker server and the controller server. These shared components include a Raft manager, a snapshot generator, and a metadata loader. Okay, so that's, I don't know if these are global, but they seem like they might be just globals that are shared between the two things. And it's the stuff they told us. The Raft manager for communicating a shared sense of coordination among the different machines. A snapshot generator for generating snapshots of what, I'm not sure, and a metadata loader. Which metadata, I'm not sure, but presumably similar metadata that you get when you talk to the Bootstrap server. So essentially a map of which topics are where. Give me 1 second. We'll be right back. So the broker server is a server that runs in craft mode. I guess they might still have a zookeeper mode. And it can do stuff like it wait for a shutdown. It has a lock A lock, maybe V lock, the main lock. That's some middleware stuff like an authorizer plugin, a group coordinator, which is volatile, and a replica manager, which is also volatile, and a metadata cache and broker topic stats, and so on. Kafka Yammer metrics, whatever Yammer is, maybe some metric thingy. Maybe change status. From process status to process status is a Boolean. Maybe indicates whether it succeeded. So we're going to lock. And once we have the lock, we're going to, if the status is not equal to from. Oh, okay, so if we're not in the from status, we return false. Otherwise, we are in the from status. We'll set status to 2, which is saved because we've locked it. And if 2 is shut down, we're going to call the shutdown signal. And then we're going to update the lock, and we're going to return untrue because this is Scala, and in functional languages in general, the last thing is the return value. Okay, and then we have a replica manager, which is set the underscore replica manager. I guess that's maybe just a getter. And I think that was volatile. I'm not really sure. I'm not going to go find it. And then startup is going to do startup. And I guess in this case, we might as well read a little bit of this startup because that'll possibly tell us like what the most important stuff here is. We're going to initialize some metrics. We've got some quota factory for managing quota. A dynamic broker config, read dynamic broker config from snapshot with graph manager. So the snapshots, I guess, are maybe snapshots of the state of Kafka. And then we've got a Kafka scheduler, which takes some config, maybe background threads is just the number of background threads, and then we're going to do call startup on the scheduler and get some statistics, set up the metadata cache, create a log manager, but don't start it because we need to delay any potential unclean shutdown log recovery until we catch up on the metadata log and have up-to-date topic and broker configs. So we're going to start the log manager. I think that since Kafka is all about logging as its database, I'm thinking that this is the log manager in the sense that it's like managing the user data as opposed to like logging information about the server. I'm not positive. But the log manager is going to take some config, some meta props on solvable error logged as Scala to sec, whatever that is. Maybe it is error logging. Maybe that's why it needs this. And it's got the metadata cache in this Kafka scheduler in time and broker topic stats and logged error failure channel. Yeah, so maybe it really is the user data logger, but it just needs to know where to log errors as well. Or maybe it handles both. I don't know. Here's the lifecycle manager. It's going to be a new broker lifecycle manager with some config, the time. I'm more and more convinced that this is just like a clock, essentially, a source of time. And then we have the token cache. Enable delegation token cache for all Scram mechanisms to simplify dynamic update. Whatever that is, man. And some futures. We're basically waiting for some logging stuff. Controller quorum voters feature. All right. And some API version manager, some other more caching stuff with listeners, and a socket server. Create and start the socket server acceptor threads so that the bound port is known. Delay starting processors until the end of the initialization sequence. So we're going to presumably open some sockets. But their processors, which may be like handlers, are not going to do anything until later. We finished starting up to the right place, essentially. And then we have listener info, alter partition manager, and we've got log context, network utils, etc., etc. Node to controller channel manager impl. It's some assignment channel manager. I don't know what channels are yet. And some action queue. Move this action queue to handle thread so we can simplify concurrency handling. And then we have a replica manager. Okay. So we've got all this stuff. I think that now, at least I know a little bit more. We'll ignore the broker lifecycle manager, I think. There's a couple of things I want to see. One is I want to see the replica manager. I don't think that we saw that yet. Replica manager.scala. What do you know? Okay, this is long. Replica manager. We've got a Kafka config metrics, scheduler, log manager, quota manager. We've got all the things, all the config, including the delayed, shared, batch, purgatory param, and so forth. And unfortunately, the Scala style is very verbose, possibly even more verbose than Java, because everything has to be a function now. But these are really just data, it looks like. This local broker ID, all partitions, log failure handler, etc., replica, blah, 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 partition count. But I wonder some methods that some replicas are handled. Here's startup of the replica manager. We're going to call scheduler.schedule ISR expiration. And then pass in some functions, which might be callbacks, might be like startup functions, including maybe shrink ISR or replica lag time maxims. I'm just now thinking it isn't append-only log, except it's maybe being compactified or compressed. And that might be why that might be what the high watermark thing was about. I don't know. And then we're also going to schedule shutdown idle replica after a logged or thread, passing in this function. And then we're setting the log to failure handler, starting the failure handler, and then add partitions to transaction manager. Dot for each. We're going to start. So I guess this was maybe passed in when we created the replica or something, or maybe we computed it somehow above, but it's not passed directly into startup. And then the remote log manager, for each, we're going to set delayed operation purgatory to the delayed remote list offset purgatory. Okay, so we're starting to the partitions, or maybe the partition managers. We're starting some per partition code somewhere as part of the replica manager. This seems to be like the main thing that we're doing, and also maybe some logging stuff. Maybe remove topic metrics. I don't care so much about metrics. Complete delayed fetch requests. Complete any local follower fetches that have been unblocked since new data is available from the leader for one or more partitions. Should only be called by replica fetcher thread after successfully replicating from the leader. Okay, maybe add listener. Registers the provided listener to the partition if and only if the partition is online. So we're going to get the partition, and if it's a hosted partition online of partition, then we're going to call maybe add listener on the listener. So I guess partition also has a maybe add listener. So we're just delegating to the partition's listeners. And in this case, it's basically a failure and say false. We can remove listener, and again, we're delegating to the partition's listeners. And we can stop the given partitions. So it seems like replica manager is mainly more or less a struct of multiple partitions that delegates to them and has some logic for reasoning about a collection of partitions. You can create a partition, and you pass it a topic partition, and it returns a partition. It says, and we get partition equals partition of topic partition time this. So with this, I guess we're passing in the replica manager, and that might set some of the stuff. That might set a bunch of stuff kind of based on what the replica manager is. And we'll call add online partition, the topic partition, and it's saying now this thing is online, and also it maps whatever topic partition is to the partition implementation And then we're going to return the partition implementation. And add online partition is just calling all partitions.put. So some map. And literally, this is just mapping the topic partition, which seems like either metadata or like a partition name or something along those lines, and into hosted partition online of partition. So I think, who was it? DeepSeek told us that if a topic is like a book title, so the book or a book title, we'll look at it in a second, then a partition is like a chapter. Let's see what they said. So a topic is like a book title, and a partition is a chapter in that book. Okay. Let's say you said this. So what is a topic partition? They may not know what a topic partition is. They give it a 50-50 chance. That's an excellent question. It gets to the very heart of how Kafka organizes data. Yeah, it does. It really is a great question. So the topic is the book's title, like Lord of the Rings. A partition is a specific volume of the series, like the Fellowship of the Rings. Oh, we've changed your metaphor, man. But that's fine. And the topic partition is the unique identifier for a specific topic. It's the Fellowship of the Ring, Partition 1, Lord of the Rings. No, wait, hang on. Yeah, no, okay, that's good. For example, if you have a topic named user click events, the complete list of topic partitions would be user click events -0, 1, 2, 3. There's no ordering guarantee between click event 0, blah, blah, blah. So what's the distinction between click events 1, 2, and 3 here? I'm guessing they might be mouse buttons, but it might just be like, what's the word? Shards, somehow. Excellent question. But the specific events they hold. How events are assigned is blah, 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 blah. Okay, I guess it doesn't matter. So just this all the things whose IDs hash the partition 1. Okay, so in this case, they're using like user ID to be, what is it, the key? If the producer sends messages without a key, the events will be distributed roughly evenly, but with no logical grouping, just round robin. Okay, so you have, I guess at least if you believe DeepSeek, I'm not sure how much I believe it, because I haven't used it much. But it's saying that you have some key, which in this case are user ID, and so all the user's data lives in one partition, or something along those lines. But at any rate, the topic partition is like a kind of like a title together with the chapter name, is what DeepSeek is telling me, and this is mapping it to its implementation, really, like what the actual underlying data is. And this is essentially its name. And an online partition is just what? It's like a getter. This is just a getter for the online partitions, it looks like. Okay. So all this looks reasonable. Append records to leader. This is the sort of thing I came here for. And append messages to the leader replicas of the partition without waiting on replication. Noted that all pending delayed check operations are stored in a queue. So we're going to, I guess, append and then also in queue a bunch of operations. And these are pending delayed check operations, and they're stored in a queue. All callers to replica manager append records are expected to call action queue try complete actions for all affected partitions without holding any conflicting locks. Okay, so basically we've locked it, I guess like kind of optimistically. And we're going to write all of the data, and that's going to succeed. And then we're going to be like, by the way, is the data we wrote like coherent, or is it all a bunch of bollocks? And I guess that's what the try complete actions is about. So you're supposed to do that after you let go of the lock, so that other people can continue writing. And we have required acts. This is only used to ensure that the append meets the required acts. Okay. Internal topic allowed. So this is whether you can append to internal topics. Seems weird that that's the caller's responsibility to allow that, but what do I know? The origin of the append request, like client, replication, or coordinator. That makes sense. Entries per partition, if the records per topic are blah, blah, blah. These are the records per topic partition to be appended. So these are the things that you're going to append, as in the actual data in your database setting. Request local action queue and verification guards. That's kind of one thing that I'm noticing here is that, like, and maybe that's the strength of Kafka, or maybe it's not a strength, but it's not clear what is like user data path stuff versus like control path stuff versus logging. It kind of all seems to be in the file reading. It all seems to be given the same kind of like priority, or there's not a clear hierarchy or separation. But at any rate, so we're going to have this append records leader function. So it's going to start in milliseconds, which we're going to get timed on milliseconds, confirming that this is really a clock. And append to local log, internal, basically the stuff we passed in. It's going to give us a local produce results with topic ID. And then we're going to call add complete purgatory action. I don't know why they call it purgatory, but we're going to take the action queue and I guess pass in all of this thing we got back after calling it append to local log. And then we're going to return the local produce results with topic ID, which is the thing that we computed here. So really this is a call to append local log that's also enqueuing some stuff here. Okay. Append records. This was what? Append records to leader. Here's append records, not necessarily just leader. Append messages to leader replicas of the partition and wait for them to be replicated to other replicas. Okay, so this is just going to do the same thing, so it's going to wait for replication. And again, we're going to get the local produce results. But not with topic ID, or at least we're not going to name it such. And then we're going to call build produce partition status on the local produce results. It's going to give us a produce status. That's going to give us a produce status. And then we are going to call record validation stats callback. All right, and then passing in, we're going to take the local produce results, map some like looking at the keys and values. For each key value pair, we're going to map the key to the values record validation stats. So that's basically the stats for all of the things. And then we're going to call maybe add delayed produce, required acts, timeout, etc., etc. And I'm not sure explicitly where we wait for stuff, but maybe this object is kind of like has a future equality where you can now wait for it or something. And here is handle produce append. Handles the produce request by starting any transactional verification before appending. Okay, so this is going to handle the transactions, I guess. Handle produce append. We're going to get some transactional producer info by looking some stuff. We're going to create a hash map, a hash set, I guess, for holding that info. Similarly with the topic, partition, batch info, etc., etc. We've got a post verification callback, which has a new request local, or rather a request local and some map of results. And I'm going to ignore its implementation. And then we're going to call append records. and then look at the transactional producer info size and do transactional stuff. Cool. Now what I want to see is this append local function. Let's see if that's here. No? What was the first one? Append something. Append records to leaders. And then what's the this local thing? Append to local log. All right. Append to local log. Append the messages to the local replica logs. Okay. We've got some map that mapped a topic ID partition to a log append result. We've got this process failed record. We're just defining some function, I guess. If trace enabled, we do some stuff. I guess I'll ignore trace enabled. What? I think I ignored all the things. Process failed record. So if trace enabled, all of this else goes to this if, and similar with that catch. So what do we actually do if trace is not enabled? We must just do this stuff. No. No, this is just defining the map. Wait, what? I'm confused about something here. So this defines a map. And I don't know. Let's just read it more closely. Okay, so this seems to be as part of the process failed record. So the log start offset is equal to the online partition of taking the topic ID partition, mapping, I guess like getting the log start offset, or else setting it to -1 as a long, doing some stats like marking a failure. Doing more stats. Whatever T is some throwable, and then we're going to match invalid producer epic exception, etc. If trace is enabled, oh, I'm sorry. So trace doesn't go all the way down here. Trace just ends here. There's no brace. Okay, that's what was confusing me. Otherwise, so the entries per partition is the thing that we passed in, right? Right? Yes, that's our data. So all of the data, which is I guess all the data are going to be a map, or rather a tuple of topic ID partition and records. So this is essentially the name of the partition that we saw before, and these are the records to append to them. We're going to do some stats, and I don't care about metrics right now, so I'm going to ignore them. And here is reject appending to internal topics if it is not allowed. If the topic's internal and the client has said that they don't allow appending to internal, we're going to reject it. Otherwise, here we are. This is the classic style of the happy path. It's hard to find because it's like under an else condition under all the error handling. Okay, so this seems to be the actual work that we're trying to do. We're going to try and maybe catch some error. We're going to call get partition or exception. And if that fails, it's going to return an exception rather than like an error value. Rather, it's going to throw an exception rather than an error value, and that'll be caught by wherever the catch is down here. So we're going to assume under the try block that we've got a partition. Then we're going to call append records to leader on the partition. The records, the origin, the required acts, the request local. So again, it seems like partition's doing all the work here. We did look at the partition before, but we can now that we know that one of the methods seems to be more important than the others, we can try to find that particular method. Before it was kind of like finding a needle in a haystack. And we've got some verification guards that we're also, I guess, passing in, and we're going to try to get them with get or else. And the number of appended messages, so this returns info, the actual appending returns info, and we're going to get the number of append messages. Then we're going to update stats and check if trace is enabled, and so on, and catch some stuff. Okay, so now, let's find partition again. I don't think it's in this directory. Partition, I think it's the Scala one, right? Partition.scala. And the figure what it's called is called append to append record. Oh, whoa. Append records to leaders. Here you go. Okay, so append records to leaders, this seems like the main function, possibly, for appending at least. We are going to say that we are in the read lock. So we're going to read it first, I think, and then we're going to get a write lock, hopefully. Whatever this is, it's going to return the info with the leader HW incremented. I guess HW can't be hardware. I don't know what it is. High watermark. Let's look up Kafka high watermark. Look. A medium post that defines its terms in the first sentence. This is amazing. Thank you, Kamani Kamal. In Apache Kafka, the high watermark is the offset of the last message that has been successfully replicated to all replicas of our partition. Okay, so it's not the watermark of replication size, it's the watermark of where we finished replicating. Okay, so inside of this read lock, we're going to call ledger log if local. Ledger log if local. I guess we're going to do a ledger log, but only if we are in a local partition, maybe as opposed to a remote partition. And if we get some leader log, then effective effective m in min ISR, so the minimum stuff that's been synced, I guess, of the leader log, and the sync size. Avoid writing to the leader if there are not enough in-sync replicas to make it safe. Okay, well, I don't know when that would be, but I guess it's possible that you don't have enough replicas in sync to make it safe. Maybe it means its backlog is too big. If in-sync size is less than the minimum and the required ax is -1, then we'll throw a new not enough replicas exception. Okay, otherwise, we're going to set info to the leader log append as leader, and as leader, the records the this.leader epic origin request local verification guard. And we may need to increment high watermark since ISR could be down to 1. Okay, then we'll increment the high water mark. Otherwise, we don't have a leader local thingy. Then we'll throw not leader or follower exception. Leader not local for partition on broker. So we probably shouldn't have called this. Maybe between the time we called it and by the time we got down here, there was another leader election and we lost leadership or something. And then after calling that, we call info copy. If we increment the high watermark, we'll somehow, whatever this is, we'll copy it. We'll return, I guess this is maybe just returning this, whether it's increased or not increased. Is that right? Where's the return value here? Log append info should be what we return. So I don't know. Oh, no, we're just taking the info and we're mutating essentially. It seems to be probably what copying is doing. Okay, so the actual writing is from append as leader. And the leader log seems to actually be for data writing. Replicated log. It's in the Raft. Is this Raft Java or Raft Scala? Okay, so cool. Here's the append. Oh, this is just an interface. Write a set of records to the local leader log. These messages will either be written atomically in a single batch, or the call will fail and raise an exception. I think that if DeepSeek is right, or whoever was telling us this, if this is really just the log is literally just files, then append as leader is probably a boring function. Although we don't really know what the records are, and it probably doesn't matter because it's just there's going to be some like binary data, presumably. Maybe it's all just ASCII text. I don't know. So here's a Scala implementation of the whatever interface that has append as leader. If the size of bytes is 0, then we're trying to write an empty record set, and we can't do that. Otherwise, we call handle and convert log append as leader, records as instance memory records epic, and append origin Raft leader. What does append as follower do? I'm guessing this is for replication. Handle and convert log append info, log append as follower. Okay, great. That's the Kafka metadata log. But where's log.append as leader? Log unified log, storage internals. This looks promising. Okay, almost. Now we're calling return append as leader. So do we get this function anywhere? This is where we are now, 999. Maybe 1010. Maybe 1024. This is probably just calling it, let's see, with a different number of arguments. So maybe, here we go. I think this is probably the one that everyone's calling, the one with the most arguments. We're going to say Boolean validate and assign offsets is whether the origin is equal to Raft leader. So I guess, like, is it coming from the Raft leader? And then we're going to call append, passing the records and all this stuff. So now we need to find what append is. I'm guessing append is probably private. No? If I had proper tags, I could find out what this thing is. Although maybe, here we go. This looks promising here. Append this message to the active segment of the local log, rolling over to a fresh segment if necessary. I don't know what a segment is. Maybe a segment's actually a file. Maybe flush metadata file. Analyze and validate records. We want to ensure that the partition metadata file is written to the logger before any log data is written. This will ensure that any log data can be recovered with the correct topic ID in the case of failure. So we're going to analyze and validate the records. Presumably just basically a sanity check. Return if we have no valid messages, or if it's a duplicate of the last append entry. If append info valid bytes is less than or equal to 0, return append info. I don't know where the duplicate is. Maybe valid bytes is 0 if it's a duplicate somehow. Otherwise, trim any invalid bytes or partial messages before appending it to the on-disk log. So we're going to lose partial messages. I don't know if that's tracked elsewhere. Like if you don't know that a message was partial, hopefully you get back some indication that some of your stuff was written, but not all of it. So we're going to trim invalid bytes. they are valid. Insert them in the log. Now, what we don't know, though, after we've trimmed the invalid bytes, we don't know if there are any bytes left. I guess maybe that's somehow known by the definition of valid. Whoever maybe analyzed and validated records. Yeah, I guess it would return. It would say that there is 0 valid bytes if after trimming you get 0. Okay. Although we don't see. Oh yeah, we do use append info here. Okay, great. And we're going to be synchronized on the lock. Why are we returning maybe handle IO exception? I don't know. This maybe is just like wrapping this somehow. Yeah, if there's an error, we might do error things. Otherwise, I guess we're going to set the valid records to the trimmed records that we got here by trimming all the invalid stuff. We're going to check if memory mapped buffer is closed. Hopefully it's not. If validate and assign offsets, I guess it's a user, something the user can pass in, then we will assign offsets to the message sets by calling locate the local log, get the log and offset, and we'll set appended first offset to the offset value, and then some compression stuff. Look at this target compression, and then we have a new log validator passing the valid records with topic partition and some other stuff. Validate and offset blah blah. We're going to call validate message. I thought we already validated the messages, but maybe this is a different kind of validation. Maybe this is like user configurable validation or something. Validate and offset assign result, the validated records. So we're going to somehow and offset assign result. Somehow down here we've got the valid records, and they have something to do with offsets being assigned. I'm not sure internally what this data structure is. We're going to append rather. No. In the append info, we're going to set the max timestamp. We're going to set the last offset to the offset.value -1. So one before the whatever offset.value is. And do some stat stuff. If we're supposed to log the append time, we're going to set that here. We're going to revalidate the messages if there's a possibility that they have changed due to recompression or message format conversion. I guess we saw some compression stuff. So if ignore record size and validate offset assign blah blah blah, then for all the valid records, I guess they come in batches. So we're going to get the batches, and for each batch, we're going to get its size in bytes. If it's bigger than the max message size, then that should not be the case after compression. One would hope that they were small enough before compressing, and after compressing they were big. Then we're going to do some stat stuff and throw an error if they're too big after whatever compression size and what else format conversion. Otherwise, we're down here, and we're going to take a look at the first or last offset first batch and check that it's less than the log and offset. And you may still be able to recover if the log is empty. This is maybe some error condition, is that right? It means we're not invalid. Validating something offsets, possibly. I'm not really sure what else condition this is. I don't know if this is error condition. I think down here is the success path. So this is throwing an exception. So again, I'm getting the batches for each. If batch magic is bigger than the magic value of v2, then we're going to assign epic start offset, passing in the partition leader epic in the batch offset. Otherwise, I guess we do want this to be bigger. I think this is maybe an error condition. In partial upgrades in areas, we may get a temporary regression to the message format. In order to ensure the safety of leader election, we clear the epic cache so that we revert to truncation by high watermark after the next leader election. Okay. And then what? We're checking the message size that we don't exceed the segment size. We might roll the segment. I don't know what a log segment is. A partition is perfectly split into segments, which are the actual files on disk. I think that's my theory, right? That the segments are the actual files, and then I don't know what a partition, I guess, is like a group of files, including the index and maybe the log. Maybe .log is the segment, and there are also snapshots and maybe time indices. Okay. So we might need to roll to a new segment. We've also got this log offset metadata. Now that we have valid records, offsets assigned, and timestamps updated, we need to validate the idempotent / transactional state of the producers and collect some metadata. So that's metadata stuff. If resolved, maybe duplicate is present. Might do some duplication stuff. And somewhere, hopefully we actually write the data. Local log dot append, appending for the last offset, valid records. Update high watermark. Okay, so I think this is the actual append, which is maybe here. Append. So I think that when we call this, we've done all of the validation stuff. We're going to call maybe flush metadata file. No. This is where we just were. This is where we just were. But maybe now we're calling it with, I don't know, what is local log? Local log is local log. Unified log has a local log, which is also the name of the type. Let's see if we can find local log. Internal. Public class local log, okay. Does it have append? And append only log for storing messages locally. This log is a sequence of log statements. Okay. Okay, so public append log calls update log and offset segments, but active segments. Okay, so ultimately we're again delegating once more to the segments, and we're getting the active segment and then calling append on the segments. Let's see if we can find segment something Java. And this is internals.log. Or rather, no. This is streams. I don't really know what a stream is. This is, I don't know if I want log segment or the stream segment. But let's see if we can find, here's append for the segment. If we look at the record size, ensure offset and range, log append bytes is equal to log.append records. Another delegation. But what is log in this case? There's .log is equal to log. Log segment is a file records. I feel like we're getting close to actually see some data written. So in file records, under append, again, we look at the size and bytes and do some error handling. And we're going to call records write fully to a channel. And I guess is what's written. And then it'll say size, get, and add of written and return written. What is records? Here's right to. Oh, memory records. That's it. Maybe no. Write fully to channel. Okay, so no, we're saying, hey records, you should write fully to the channel. And then the question is, what is the channel? its own file. Okay. That's good enough for me. They say reading the code is as important as writing. Great job. Thank you, Scholar's Corner. And with that, I think I'm going to leave Kafka. It looks cool. I like in theory the idea of the database being just append-only logs. It seems like in practice people enjoy it. I don't know really what the downsides are, and I don't have a good way of evaluating. I don't have a size enough infrastructure or needs to like evaluate middleware. Like you would if you were a giant Fortune 50 corporation. So I'm sure that any of these solutions would work pretty well for the most part. But it seems cool. The code is fine. Like, for the most part, it's easy to read, except that, as I said before, first of all, it's hard to dig into where the actual data gets written. There are lots of layers of indirection. And I'm not sure if anyone really on the team is keeping all of the layers of indirection in their head mentally, or if it's just like everyone has to ultimately chase down to figure out where the actual work happens. But that's not entirely uncommon in Java. That's not my favorite style, but it's not particular to Kafka. I think it's a pretty Java-esque style of the Java ecosystem. And the other thing that was a little bit confusing code reading wise is I think this is more of a Scala problem, but it's there's not a really clean delineation about which functions are important. And by important, I mean like they're on like the hot data path. So if you wanted to optimize something like this, it would be difficult to do it without tooling like this would be the sort of code base where you probably would want to run a debugger to see what's actually being called, because there are just so many methods that it's hard to focus in just looking at the code as much as in some other code bases. But with those two caveats, it seems cool. And I enjoyed it. I hope you enjoyed it. I'll see you guys again next week. Thanks for joining me on this exploration of source code. This has been Ants Are Everywhere.